Hello students, this is my friend Rita. Yesterday, she was playing with a bar magnet, a U-shaped magnet, some iron filings and a few iron nails, during which she found out a few interesting things about magnets. Let's find out what she did and the interesting discovery that she had. She kept the magnets on a table and placed two nails right opposite the two magnets at some distance from them. Initially, she saw that the nails were not attracted by the magnets. But as soon as she placed the nails closer to them, they were pulled by the magnets. She then removed the nails from the table and sprinkled iron filings around the magnets. After sprinkling the iron filings, she tapped the table and observed that the iron filings arranged themselves in curved lines around the magnets. What could these curved lines around the magnet be? Let us find out in this video. The force exerted by a magnet can be experienced by magnetic materials in a region around the magnet. So, the magnetic materials, such as iron nails, are attracted to the magnet only when kept in this region. This region is known as the magnetic field of a magnet. When Rita placed the nail initially at some distance from the bar magnet, the magnetic force exerted by the magnet on the nail was too small. When she placed the nail closer to the magnet, the magnetic field exerted a greater force on the nail and attracted it towards the magnet. The magnetic field is invisible, but its presence can be visualized in the form of curved lines around the magnet. These are the lines that Rita saw when she sprinkled iron filings around the magnets. These lines are known as magnetic field lines. Do you think that these lines are present only on the tabletop on which Rita placed the magnets? No. The magnetic field lines of a magnet are present all around it. This is why the magnetic force of a magnet can be experienced all around it. Outside a magnet, the direction of magnetic field lines is from the North Pole to the South Pole. Whereas inside the magnet, the direction of magnetic field lines is from the South Pole to the North Pole. Thus, the magnetic field lines form closed loops. When Rita placed a bar magnet and a U-shaped magnet on the table and sprinkled iron filings around them, the iron filings arranged themselves along the magnetic field lines of each magnet. Outside the magnet, they emerged from the North Pole and merged at the South Pole. This is shown with the help of arrows. It was observed that most of the iron filings were stuck to the poles of the magnets. This is because the magnetic field lines are crowded or concentrated at the poles. This makes the magnetic field strongest at the poles of a magnet. Let's summarize what we have learned today. The force exerted by a magnet can be experienced by magnetic materials in a region around the magnet. This region is known as the magnetic field of a magnet. The magnetic field lines represent the direction of the magnetic field. Outside a magnet, the direction of magnetic field lines is from the North Pole to the South Pole. Whereas inside the magnet, it is from the South Pole to the North Pole. The magnetic field lines are crowded near the poles, indicating the presence of a stronger magnetic field near the poles. Bye-bye. Happy learning!